Okay, so today's Java 2, lesson 8, which is also the last lesson. And today we're learning about something called random numbers. So by random numbers, I don't mean like random numbers as in like whatever number you want. I mean how to generate random numbers. So like it says here, in this lesson, we'll be talking about how to generate random numbers. And the basic form of it is math.random. And so this returns a random number from 0 to 1, and that's not 1. So anything between 0 and 1, that's a double, then you can generate it there using that command. Yeah, and also if you have any questions, just put it down in the chat below and I'll get it to it. But I'm not going to be pausing for questions right now. But anyways. So the official method is of the math class, this. And you don't know methods yet, but I'll be teaching it in Java 3. So if you go to Java 3, then you'll be learning about that. But just for your knowledge right now, the official method of it right now is this. So basically, if you go to Java 3 and you learn it, then feel free to come back to this, and so that now you know what the official form of it is now. But yeah, it's not something you need to know right now. So an example of using this is, so we put this math.random inside of a print statement. And you can see in this output, and this is like a sample answer, since of course, when you're generating random numbers, there's a lot of things you can come up with. So it's a sample answer. And so I picked 3 answers that it could possibly output. And you can see it here. So this is 1, this is 2, this is 3. And you can see that all of these have like an extremely long double length. Like, I don't know how many letters this is. But you can see here that if there's so many, like every single time you run this math.random, it's going to generate a double of this length. So however many numbers there are in this. And so you can see that there's a lot of different outputs. So it'll like guarantee that you're going to get a random number. Almost guarantee that is. So to generate numbers with a certain range. So of course, when you're doing random numbers, you often don't want it to only be between 0 and 1. So this is a way to broaden that range. So an example of how you might program numbers to generate numbers with a certain range. You do math.random, which is the one we just used, times 3. And this would generate a random number from 0 to 3, excluding 3. 3 can be replaced with any other number, including doubles. And in all these following slides, you can replace range numbers with doubles. So just keep in mind, there's a lot of ways you can change the range of your outputs, and I'll be going over that later, but just know that you can replace these with doubles. So why this statement does what it does, like generating a random number from 0 to 3, is because this the statement first generates a number from 0 to 1, courtesy of this math.random. So it first looks at this and it generates a random number, excluding 1. But then it multiplies the number by 3, signified by this times 3. So that's why the number, like the range, goes from 0 to 3 now. Again, to generate numbers with a certain range. And this is another different example. So you can see here that I have the same math.random, but this time, instead of multiplying something, I add 5. And what this does, it generates a random number from 5 to 6, and 5 can be replaced with any other number. And of course, this goes from 5 to 6, including 6. So this is because this statement first generates a random number from 0 to 1, excluding 1. So courtesy of this statement. And then it adds 5 to that number. So that's why you get 5 to 6. Complex ranges. So for this one, I have like a formula of sorts. So, but like I have an example afterwards so that you can like see. But this is like the official formula for it. So the general implementation is something like this. So you have the math.random statement, and then times something inside parentheses b minus a, and then plus a. So this generates a random number from a to b, excluding b. And I know this is confusing, but I'll like go back and forth between the example slides so that you can like get it comfortable. So again, you can put any number in replacement of a and b, and it doesn't matter whether a is bigger than b or b is bigger than a. So this is an example of the previous slide. So you can see that I have this thing inside a print statement. And so notice here I have in parentheses here 5 minus 3. And if we go back to this slide and we look at this one, you have 5. We had 5 minus 3 in place of this. So that means that a is 3 and b is 5. So that means that this example slide generates a random number from 3 to 5 because a is 3 and b is 5, excluding b. And see, I have it here. So the range is from 3 to 5, not including 5. And the sample answers, since of course, again, you can't have exact answers with random numbers, would look something like this. And just notice that it's called, well, I call it complex ranges because instead of just going from 0 to like 5 or 4 to 5, it goes from one range that you specifically say yourself and the other range. So this is more complex, but it's also more, it allows more freedom with random numbers. Also notice that in this statement, you actually don't have to write it inside parentheses like this. You can just write it as 2, since 5 minus 3 is 2. So you can just write 2 in place of this parentheses part, and it would still work. It would still have a range from 3 to 5. I just wrote it like this so that you can see it more clearly. But you can write it either way. So random integers. So of course you probably don't want doubles all of the time, and you're probably gonna want something like random numbers from 0 to 10, that kind of stuff. So an example of how to do it would be something like this. So you see here that we have a math.random here, and then we times 10. So if we just look at this part alone, then this would generate random numbers from 0 to 10, technically, excluding 10. But because of this int here, so remember we learned about casting like a little bit ago, and so what this does is it first generates a random number from 0 to 10, not including 10, and then it casts it to an int. So if you remember what this does, it completely chops off that decimal part. So this ends up generating a random integer from 0 to 9, inclusive. You could also say it as 0 to 10, not including 10, and it would also be the same thing. I just say 0 to 9. So again, 10 can be replaced with any other number. So this generates an integer instead of a double. Casting to an int is how you do this. So make sure you know casting well, and I'm sure all of you know it well. So note, you can cast any of the aforementioned statements to integers by using this method, which is casting. Random integers to certain ranges. General implementation, something like this. Again, it's a formula, and I have like a example to make it easier to understand. So yeah, you can see here that we have a math.random times k, something called k, and then plus n. So there's a problem. Okay, I have to fix something. I have to add another parentheses. But when this executes, it should generate a complex range, like the other slide where I went over complex ranges. But instead of just letting it be a double, this time we're casting it to an int. So this generates a random integer from n to n plus k minus 1. And it's confusing, but you'll see in a second. Inclusive. So again, you can replace k and n with any number. And note, this statement is pretty similar to the other formula statement, except it's just with integers. So you can honestly use any of these two and it still work the same. So you can use this one, you can use the other one. It doesn't really matter. The only reason I'm showing this specifically this time is because in this, I'm casting it to an integer. So example. So you can see here that we have this right here. And you can see, okay, so 5, I think this was k, I believe. Wait, let me check. Okay, so this is k, this is n, right? So 5 is k, 3 is n. So in this case, the range would be from 3 to 3 plus k, which is 5, which becomes 8 minus 1. So that's 7. So it becomes from 3 to 7. And you can see here that it's 3 to 7 inclusive for this range. And sample answer, and you get 6, 6, and 7, since you cast it to an integer. Yeah, that is the lesson. It's a lot of information to take down all at once, but with some practice and reviewing, I'm sure you guys will get it. And I'm going to be showing the class problems soon, maybe. Okay, so these are the class problems for this lesson. Now, so these top part is the regular problems, and this down here is like the challenge problems. First do these, and then do these if you feel comfortable. But yeah, otherwise, just make sure you're familiar with this. Again, this is the last lesson, so be sure to review all the other lessons just to make sure that you got it down good for both the review class and the test that is coming up. But otherwise, that would be it for this lesson.